Continuation of problem number 2 for the same Boda plot. So the control system having g of s k into 1 plus 0.5s into divided by s into 1 plus 2s 1 plus 0.05s plus 0.125 s square. So this is some more different because here in the denominator quadratic equation is there, and all this both the values should be converted in already converted to time constant form. Draw the Boda plot with k equal to 4. Find the gain margin and phase margin. So everything steps will be same. First step is identify the factors. So k equal to 4 because already given. Then 20 log k equal to 12 dB. So 20 log, put the k value. 20 log 4 means 12 dB. So then the first pole 1 by s, one pole at origin. So its slope is minus 20 dB. Then second factor 1 over 1 plus 2s, 1 over 1 plus 2s. So pole at second pole at t1 means if you compare with the standard time constant, we will directly get 2. Then omega c1 is equal to 1 by t1. Then next factor is numerator term, that is zeros. So 1 zeros, so t2 is 0.5. Then consider this quadratic term. So somehow different means the selection of quadratic term. How to calculate the corner frequency? So to calculate the corner frequency, compare with standard equation. So this is the standard equation in the Boda plot. So in the Boda plot, we can use the standard equation to find the value of corner frequency. So compare the standard loss coefficient 1 over omega n square equal to 0.25. S square is there. So 1 over omega n square is equal to 0.25. So omega n square is equal to 1 over 0.25 means 8. We'll get this. Then omega n is equal to 2.83. Okay, that is called as third corner frequency. So then same as obtain the magnitude plot. So to obtain the magnitude plot, just observe your magnitude plot. Same factor in the first column, frequency in the second column, slope line in the third column. So first factor 1 by s means one pole at origin. So magnitude is minus 20 dB per decade. Then the next factor 1 over 1 plus 2s. So that is also present in denominator, means it is pole. Slope is minus, again add with the minus 20. Omega c1 is 0.5, minus 20, minus 20. You will get minus 40. Then next factor is numerator factor. So for numerator factor, the corner frequency is 2. So here it is numerator factor. Numerator factor means the slope value will be start from plus 20 dB per decade. Previously it is minus 40. If you are adding plus 20, you will get minus 20 dB per decade. Next is 1 over 1 plus quadratic equation. For this quadratic term, the corner frequency is 2.83. But the slope is minus 20, minus 40. Why you are getting consider this minus 40 means it is a quadratic factor. If the factor is quadratic, we have to consider the slope. If it is a numerator quadratic factor means slope is plus 40 dB per decade. If it is denominator quadratic factor means minus 40 dB per decade. So you will get minus 60 dB. So then to calculate the phase angle plot, so replace s by j omega in the given problem, because the given problem already is in standard time constant form. So we will get this, wherever s is there, substitute j omega. So if you substitute the j omega, we will get the equation like this. After substituting the j omega, we can rewrite the equation, that is the denominator term. So because while applying the trigonometry calculation of phase angle table, we need to convert it into some constant form. So here same thing, omega. So we can start from 0.2 to infinity. In between 0.2 to infinity, you can consider the three corner frequency. First is 2, then 2.83. So here 0.5, then consider the next corner frequency. Clear? So 1 by j omega means it is 90 degree. Then consider this factor. So in numerator only it is present. So there is no, apply the trigonometric formula. How to apply means it is tan inverse of 0.5 omega by 1. 0.5 omega by 1 means it is 0.5 omega. Then second factor tan inverse of 2 omega. Then the third factor, which is a quadratic, this factor we can rewrite from the previous step. So we will get minus tan inverse of, this is imaginary term 0.05 omega, this is the real term is 1 minus 0.25 omega square. So we have to substitute the omega equal to this values, omega equal to this value 0.2 to 2.2, so on. Then you will get the corresponding angle plot. Finally, the resultant phase angle, you can add all the values. Minus 90 plus, just look at your minus 90 plus 5.71 minus 21.8 minus 0.57. If you are adding all the values, the resultant angle will get 106.6. Similarly, you can do the calculation for all the steps. Clear? So we will get the values. Then if you are observing the plot, how the graph will be appear. So if the plotting the graph, we will get the nature of plot, which will be as shown in the figure. So that nature of plot, which is obtained so this is the nature of plot what we observed here. So nature of plot for this here. Same procedure, draw the 0 dB, then you can mark the points here, then phase angle plot will be below here. 12 dB is drawn, clear, that is 12 dB per decade. 12 dB is drawn here, clear. Then so draw the slope line. So from the 0 dB to this atomic is equal to 1, draw the all the three slope lines. Just observe minus 20, 40, 60. The first corner frequency from the table we will get 0.5. So 0.5 means somewhere here, clear. This is the 0.5. This slope line parallel to 20 dB, because from the magnitude plot or magnitude table we are observing this. So this slope line is parallel to minus 20 dB per decade. You can draw it. Next corner frequency after from the calculation, it is 2. So 2 is here. Draw the slope line from 0.5 to 2. 0.5 to 2. This slope line parallel to 40 dB per decade. So 40 dB per decade. Next 2 to 2.83, just draw the line which is parallel to 60 dB. So small distance. Then 2.83 to infinity, which is minus 60 dB. So as for the magnitude plot, you can draw the slope line. So that will be marked here. Then phase angle plot, there is no difficulties. From omega versus phase angle, you can plot the graph. So rest of the step is same. Where it crosses 180 degree line, this is the 180 degree line crossing point projected towards magnitude plot, we will get the gain margin. And where it crosses 0 dB line, so projected towards phase angle plot, we will get the gain margin. Clear? So this is the phase margin value. So corresponding frequency, whatever you get, that will be written here. This is the steps. Clear? So similarly, the next problem we can discuss here, that is a problem number 3. So the open loop transfer function of unity feedback system which is given. So already in the standard time constant form only, determine the value of k so that it will have phase margin is given 40 degree. What will be the gain margin? Use the Bordeaux curve. So for that, first we have to write the k is unknown factor. We don't know the k, we need to find the value of k. So that's why we have to write k is unknown. Here one polar origin, you can find the values 1 by s. Then consider the factor. From the first factor it is value of second factor, then third factor. So then you can obtain the magnitude table. So this is the magnitude table, factors, frequency, slope. So first polar origin, then we will get minus 20. Next value, that is the next factor, corner frequency is 4, and this is the magnitude plot. And the third factor, corner frequency, this is the corner frequency, and this is the magnitude value. Next factor, corner frequency, and this is magnitude value. Then find the phase angle plot. So to find the phase angle plot, replace s by j omega. So that is, you can observe here, if I replace s plus j omega, we will get the values. There is no difficulties, I think. omega, 1 by j omega. This is same procedure. There is no difficulties in all the steps. So start from 0.4 to infinity. Between this 0.4 to infinity, you have to put corner frequency value 4, 10 and 1000. So we get the resultant values here. Clear? There is no changes in the values. Then the case is, if the phase margin is 40 degree, draw the horizontal line at 40 degree and 180 degree intersecting phase angle and mark the point C. So from that point we will get 20 log K is equal to 8 dB, which is upward, and K equal to 2.51. So phase margin is 40 degree. Draw the magnitude plot parallel to that without K. So with K and without K, how the graph will be look like. That will be shown in the graph, or that will be observed. You can observe in the graph. So just observe the graph. So observe here. This is the graph. Carefully you have to observe it. This is the problem number 3. Find the value of K. You will get the values. So draw the border plot which is shown in the figure. Here, this is the nature of graph. Okay. So if the phase margin is 40 degree means 180 minus 40. How much you will get? 180 minus 40 means you will get somewhere 160. Not sorry, 160, 140. 140 plus 40, it is 180 degree. Somewhere here 140 degree. For 140 degree you can draw the line. So first we have to draw the normal graph. Okay, this is the slope, we can drawing, no problem. There is no difficulties in the first slope. This is the first slope. What I marking a pen or showing in the pen point, that is the first plot. While drawing of this plot, so draw the slope line or draw the horizontal line for the phase margin which is of 40 degree. 40 degree means from the reference. 180 minus 40 means we will get 140. Mark 140, horizontal line for 140 degree. So this is the intersecting point. Consider this intersecting point projected towards magnitude plot. So from actual Bordeaux plot to actual magnitude plot to new plot. So here we will get the points. Draw the point which is direction towards upward, because so this slope is below the 0 dB. Our objective is to meet the 0 dB slope line. So we can draw the vertical lines towards upward. So this is the meeting point. Then draw the line which is parallel to this old slope. Old slope is the reference. Draw the parallel line for this slope which meets omega equal to 1 at 0 dB. Then rest of the procedure is same. So this is magnitude plot and this is phase angle plot. Then so find the values of phase margin. So that phase margin is same and gain margin is 20 log K. So here upward movement means from this point to this point, what is the values of phase margin? So sorry, gain margin, if you are observing the graphical method, this distance will be 8 dB. So that will be written here. So D to E, 20 log K is equal to 8 dB. So K equal to some values. Then phase margin is 40 degree. Draw the magnitude plot parallel to that without K, yes, to find the omega PC. Then you will get the gain margin is 12 dB per decade. So 12 dB per decade means here 180 degree crossing point. Here you can project it towards new plot. This distance A to B distance is get gain margin, that is 12 dB. This is the complete steps to solve the problem.